Hi guys, me again. I want to finish up our production possibility frontier graph today, if you will, our concepts, and then I'm going to go ahead and record some videos afterwards for trade, which is really exciting to me. I love the unit on trade. All right, so with the production possibility frontier, some of this is going to be a little bit of a refresher. So remember what we've got. We've got our two goods, right? So whatever those goods are, just going to call this one good Y and good X for the time being. And then in one of the other videos, I talked about the relationship in real life being this kind of bowed out or concave. This is really hard to do with an iPad, harder than I thought. Some type of concave to the origin production possibility frontier. Remember what that represents. That represents increasing opportunity costs. Another way of thinking about that is that not all resources are equally capable of all things, right? So from a land perspective, if I want to farm and I could pick any place in the United States, I'm going to pick the place that has the best soil for what I want to grow and the best climate. And so I'm going to get the most out of that land, right? But as my farm expands, as I need more space, whatever land I add onto it is not going to be as good as the original. How do I know? Because if that new land were better than the original, I would have chosen it first. So a little bit more about this PPF. Again, all of that should kind of be a review, but a little bit more that I want to mention is kind of what this PPF is. Sometimes I'll have test questions on that, so I want to make sure that you understand. The PPF itself, the line itself, gives you all possible combinations that you could produce. Now, you can't be at every one of those points at the same time, but you could be at any one of those points, all right? So the PPF gives you all possible combinations of what you could produce. But you can also see it referred to as a boundary between what you could produce, right? So you could always produce less than you're capable of. You could produce anywhere inside. So it's a boundary between what you can produce and what you cannot produce. Hopefully you guys are getting used to my handwriting now. All right, so any point on the line, right? So let's pick a point like A or a point like B, okay? Any point on the line, like A or B, are going to be both feasible or possible and efficient. So in this case, efficient means that we're using all of our available resources. All right, so I can use all of my resources to be at one endpoint. We saw this last class. I could use all of my resources to be at another endpoint, or I could use all of my resources to be at some point in between on that line. So points like A and B are feasible and efficient. What about a point like C here in red? Okay, so a point like C in red is both feasible but inefficient. So remember that idea of efficiency. It has to do with using all of your available resources. So at a point like C, it's possible to produce there, but it doesn't require all of my resources. So this would be like, let's say this is my production possibility frontier between, say, grading papers and getting chores done, right? And so I need to grade papers and I need to get chores done, but instead I just come home and I like veg out on the couch and, binge watch something on Netflix. If that's what happens, right, I am not using my time wisely, right? It's possible for me to do that. I probably do that more than I should. It is definitely inefficient. What about a point like D? I should have changed my color there. Let me see if I can get my colors back here. Oops, I don't know how to get my colors back. So we're just going to stick with the red momentarily. Here we go. What about a point like D, which I'm now going to go over in white? So a point like D is not feasible. You cannot produce at D. All right, so you cannot produce outside of your production possibility frontier. Why not? You simply don't have the resources. All right, so you don't have enough resources to produce beyond your PPF. Here's the beautiful thing here. You cannot produce at D, but guess what? We're going to find as we advance in our lectures, with trade, it is possible to consume at D. So this is a pretty remarkable thing that I'm saying now. I'm saying that trade is going to allow us to consume more than we can produce. And the truth is we do it all the time. I don't know about you guys, but if I think about what my life would be like if I had to say build my own car, build my own house, assemble my own electronics, I wouldn't have half the stuff that I currently have. So if you really think about it, we're all today, right, in today's day and age, we are all consuming more than we could individually produce because of the fact that we rely on trade. So this would be kind of the point in class where I might ask you guys, hey, by a show of hands, how many of you have engaged in trade in the last, week? And I'd get some little skeptical looks, and then I would say, bet you all have, right? If you've gone out to eat, if you've purchased groceries, if you've put gas in the car, right? All of those are examples of engaging in trade. Even going to work, right? You're trading your time and your knowledge, your experience, your patience if you're in customer service, right? You're trading those things in exchange for a paycheck. And why is that paycheck valuable? Because you want to use it to buy other things. So anyways, A and B, feasible and efficient. C, feasible but inefficient. D, right? It's not feasible. You cannot produce at D, right? Even with trade, you're not producing at D, but it's possible to consume here, as we'll see in the next charts. The last things I want to show you is that when we talk about these graphs, let's give you one more here, right? With good X and good Y. Is that this line, sorry that I hit my axis there too soon, is that this production possibility frontier is essentially static. It's going to stay where it is at any moment in time, right? So it's like a snapshot at any moment in time. But the truth is the PPF can change over time. It does shift, right? So as your resources change, if you're a country like Japan or Germany, Italy, and your labor force, your population is aging, right? You could have a reduction in the number of people that are working. In the United States, the only reason why we don't have that is because of immigration, if you really look at the census records. But at the same time, right, you could have other things that increase your productive abilities, right? So new technologies obviously would come into play. So if something happens that could result in an increase in your production in Y, then you're going to move this endpoint up vertically. If something happens that could increase your production of Y. And similarly, something could happen that could increase your production of X. It could be the same activity, it could be a different activity. And if those endpoints move, right, could be one, could be the other, could be both, then over time, you can move to a new production possibility frontier. So that PPF is moving over time. It's a slow movement in most areas if you're looking at like the entire economy, but it could be a quick movement in any specific industry, right? So a very, like if this is the graph specifically for, say, an office, right? So an office with 5 employees, and right now all 5 employees are sharing one printer and people are constantly having to wait their turn to print, right? What would happen if they acquired a second printer, for example, right? Their productivity just shot up, the amount of work they can get done. So anyways, that should conclude my talk on the PPF. There's also videos from Khan Academy. There's some readings from OpenStax. As always, let me know if you guys have any questions. And I'll be working on the next video shortly.